Here your y is equal to log 1 plus x upon 1 minus x raised to 1 by 4 minus 1 by 2 tan inverse x. Then we have to find out dy by dx. Now, before we go for differentiation, let's use property of log so we can simplify first term. Let's say this 1 by 4, which is within the power of bracket, can be moved to the multiplication of log, and here we have log a upon b. So it can be simplified into log a, which is log 1 plus x, minus log b, which is log 1 minus x. Your second term will be remain as it is. So we get our simplified y, and we are ready to find its differentiation. So 1 by 4 will be as it is. Differentiation of log 1 plus x will be 1 upon 1 plus x, minus differentiation of log 1 minus x will be 1 upon 1 minus x into minus 1. Minus 1 by 2. Differentiation of tan inverse x is simply 1 upon 1 plus x square. In further simplification, this minus minus become plus, and we have to take LCM. So we will get 1 minus x plus 1 plus x. And in denominator, we have 1 plus x into 1 minus x, minus 1 by 2, 1 upon 1 plus x square. So here your xx will cancel out. We will get 2 upon 1 minus x square, minus 1 by 2, 1 upon 1 plus x square. So here 2 2s are 4. So your dy by dx, so we can take 1 by 2 common. So we will get 1 upon 1 minus x square minus 1 upon 1 plus x square. Now let's take LCM again. So we'll get 1 plus x square minus 1 minus x square, or we can say plus x square, whole divided by 1 minus x square into 1 plus x square. So 1 will cancel out. We will get x square plus x square will become 2x square, and in denominator we will get 1 minus the square of x square, or we can say x raised to 4. So this 2 will cancel out, and finally your dy by dx will be x square upon 1 minus x raised to 4, which is given in option A. Ta-da! In this question, we have y is equal to tan inverse of 4x upon 1 plus 5x square plus tan inverse of 2 plus 3x upon 3 minus 2x. Then we have to find out dy by dx. Now, before we go for differentiation, we have to simplify this term. In first term, we need 2 digit having summation is equal to 4x and product is equal to 5x square. Those 2 digits are 5x and minus x. So in first term, this 4x will be simplified into 5x minus x upon 1 plus 5x into x. Now let's move to the second term. We have tan inverse 2 plus 3x upon 3 minus 2x. And to simplify this, we have to divide numerator as well as denominator by 3. So we will get 2 by 3 plus x upon 1 minus 2 by 3 into x. So in both terms, we said tan inverse of alpha plus beta upon 1 minus alpha beta, which can be simplified into tan inverse alpha plus tan inverse beta. So in first term, we will get tan inverse 5x minus tan inverse x. And in second term, we will get tan inverse 2 by 3 plus tan inverse of x. Now this tan inverse x will cancel out, and we will get y is equal to tan inverse of 5x plus tan inverse of 2 by 3. So we are ready to differentiate with respect to x. Differentiation of tan inverse phi x is 1 upon 1 plus phi x the whole square into differentiation of phi, or we can say phi, plus differentiation of tan inverse 2 by 3, which is purely constant term, will be 0. So phi upon 1 plus 25x square is your final answer, which is given in option C. In this question, we have to find differentiation of this function. Here, the outermost function is log and having 7 within the base. So let's consider the whole bracket within the box. To remove this base 7, we have to apply the change of base property. So we will get log of box, which is log x base 7 whole divided by log 7. So we are ready for differentiation. This 1 upon log 7 is constant, take it outside. Differentiation of log box will be 1 upon box into differentiation of box. Within the box, we have log x base 7. So we have to multiply differentiation of log x base 7. Now, let's say your first two terms will be as it is. And this log x base 7 can be simplified into log x upon log 7. So first two term will be as it is, and this 1 upon log 7 will also remain as it is. And we just have to differentiate this log x, which will be 1 upon x. Now to get the proper answer, let's simplify this log x base 7. It will be split into log 7 upon log x. 1 power of log 7 will be cancelled out. And this 1 upon log 7 can be rewrite as log e base 7 upon x log x. So our answer is within the option C. Ta-da! If x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 3 by 3, then we have to find out dy by dx. And for that, let's differentiate our equation with respect to x. So differentiation of x raised to 2 by 3 will be 2 by 3 x raised to 2 by 3 minus 1, or we can say minus 1 by 3, plus differentiation of y raised to 2 by 3 will be 2 by 3 y raised to minus 1 by 3 into dy by dx. And on right hand side, differentiation of a raised to 2 by 3 will be 0, because it's a purely constant term. Now let's move the term of x on the right hand side. So we will get 2 by 3 1 upon y raised to 1 by 3 dy by dx is equal to minus of 2 by 3 1 upon x raised to 1 by 3. So your 2 by 3 will cancel out, and we will get dy by dx is equal to minus y upon x whole raised to 1 by 3, which is given in option B. Ta-da! Here we have to differentiate 1 plus x square into tan inverse x. And for that, we have to apply multiplication rule. So 1 plus x square will be as it is. We have to differentiate tan inverse x. And then tan inverse x will be as it is. We have to differentiate 1 plus x square. So in first term, 1 plus x square will be as it is. Differentiation of tan inverse x is 1 upon 1 plus x square, plus tan inverse x will be as it is. Differentiation of 1 will be 0, and differentiation of x square will be 2x. So 1 plus x square will cancel out. We will get 1 plus 2x into tan inverse x, which is given in option C. Ta-da! Here we have to differentiate e raised to x plus 3 log x, or we can say we have to differentiate e raised to x e raised to 3 log x. In second term, we can further simplify by taking this 3 within the power of x by applying property of log. So here we'll get differentiation of e raised to x, and e raised to log x cube is simply x cube. So we are ready to apply multiplication rule. E raised to x will be as it is. Differentiation of x cube will be 3x square plus x cube is as it is. Differentiation of e raised to x will be e raised to x. For further simplification, we can take e raised to x and x square common. So remaining terms are 3 plus x, which is given in option A. Ta-da! Here we have y is equal to log of 1 plus root x upon 1 minus root x, and we have to find out dy by dx. So before we go for differentiation, let's apply the property of log. We have log a by b, so it can be split into log a, which is log 1 plus root x, minus log b, which is log 1 minus root x. So we are ready for differentiation. So your dy by dx will be, so we will get differentiation of log box, which is 1 upon box, into differentiation of box. Within the box, we have 1 plus root x. So we just have to multiply differentiation of 1 plus root x, which will be 0 plus 1 upon 2 root x, minus, to take differentiation of second term, we have to take box around the 1 minus root x. So we will get 1 upon box into differentiation of box. Here we have 1 minus root x within the box. So its differentiation will be 0 minus 1 upon 2 root x. In further simplification, we can say this minus minus become plus, and we can take 1 upon 2 root x common. So we will get 1 upon 1 plus root x plus 1 upon 1 minus root x. So let's take LCM. We will get 1 minus root x plus 1 plus root x upon 1 plus root x into 1 minus root x. So here we'll get root x cancel, 1 plus 1 will become 2 upon a plus b and a minus b, or we can say a square minus b square. So this 2 will cancel out, and 1 upon root x into 1 minus x is your final answer, which is given in option B. Ta-da!